All right, welcome to today's Alaska TTAP webinar on the Alaska Village Road Guide. Presenting the road guide are Nathan Belz, professor in civil and geologic engineering at the University of Alaska Fairbanks, and Billy Connor, the director of the Alaska TTAP and the Arctic Infrastructure Development Center here at the University of Alaska Fairbanks. And I'm going to hand it over to them to talk about their work on and the details of the Alaska Village Roads Guide.
Okay, thank you, Vicki. Um, as Vicki said, I'm the director of the TTAP, but also director of the Arctic Infrastructure Development Center. And if you go to the next slide, please, Nathan. Um, One of the things that we're looking at here is ultra volume, low volume roads, and that means less than 100 ADT, 100 vehicles per day. Um, and the reason for that is the requirements for those types of roads are far less than what we would expect for an interstate highway or even some of the local roads that have been looked at in the past. And what we're trying to accomplish here is really not to say this is how you're going to do it. Our focus is on meeting the needs of the rural Alaska communities, as well as ensuring the safety and the ability for you to be able to maintain and obtain the materials in that. So you're going to find that a lot of this looks like it's minimalistic, and that's by design on our part. But we can also leave you with the flexibility. A couple of disclaimers before we get started into this. One is that while the Federal Highway Administration, USDOT, and the Alaska Department of Transportation Public Facilities have reviewed this and have provided us with comments. They have not sanctioned it or endorsed it, that's for good reason. It has to go through a number of processes which they have not gone through with this manual. So that's why we're using it as suggested guidelines and not necessarily requiring that you do it and not calling it a manual as such. So be aware of that. Secondly, we encourage you to take what we've given you here and make it your own. And that means modify those areas which don't meet your needs and you would like to alter and make them fit within yours. I would suggest that you work with a highway engineer or a transportation engineer to make those changes. But I do recommend that you make them to fit your needs because for reasons that we'll talk about in a moment. Next slide, Nathan, please. Okay. A couple of acknowledgement. Adam Larson with Federal Highway, Dan Breedeman, and Ronald Eck with West Virginia University all have reviewed this and provided great input to this guide, and it certainly helped us as we went through the process. It was also was funded under the Center for Safety, Equity, and Transportation through the USDOT University Transportation Program. The center was called CSET. Next. Okay. The purpose of the guide is really pretty straightforward. We wanted to provide you with support for safe, practical road design throughout the villages. And we recognize that unlike most of the other guides that we have, that the villages have a totally different mix of vehicles. Uh, the roads and streets within the villages, the primary vehicle are typically ATVs of some sort, pedestrians, trucks, and sometimes some maintenance equipment. So we've got that mix that you're not normally going to find in other areas and of transportation and highways. So we tried to meet that requirement. And we were also trying to balance safety cost and constructability. The availability of materials and other things that you have are a little bit different or quite a bit different than you would find elsewhere. And we were trying to give you the latitude to adjust the design to meet your needs. Next. Uh, we also recognize the diversity of our villages. We have villages with less than 100 and some a number over 1,000 and everything in between. And the typical road mileage within the community ranges from slightly less than a mile to almost 4 miles, something in that range. And so we really need to understand that that's how that all fits together. Um, your roads are typically isolated. You're not connected to a major highway network. Your connection is usually to the outside world, is usually to the airport. Trips are typically less than a mile, uh, and as such, we don't really need high-speed roads for that. If it's a non-core road, we'll get into those definitions in a moment. Uh, Usually out to the airport or a landfill or something like that, typically less than 3 miles. Air transport and barge transport for getting goods and people and services in and out of the community are typically the predominant modes of transportation. Next. So our design philosophy is really uh, fairly straightforward. And first of all, safety. Safety is paramount in everything that we look at. So that comes first. But it's efficiency and affordability. We want to make sure that how you spend your dollars are efficient and that it will carry you forward. We put and flexibility over strict standards. We purposely loosened up some of the standards for you and give you a lot of latitude. And this is where when I say make it your own, um, that's going to have a number of different factors that are coming into that, including the number, your materials availability, and your climate. So take that into account as you apply this guide. And we also want to make sure that you we allow for you to accommodate the local materials. We know that the cost of barging materials in is extremely high, and is we want to try to avoid that to the extent we can, either by um, reducing the amount of material or how we are using the materials. And we also want to recognize the capabilities. Most villages have a grader, but not all. Some have loaders, many don't. And so we're just, the availability of the equipment is really critical to our thought process as we've gone through it. Next. Okay. We encourage you to do planning. In fact, under TTAP, there are funds available to you to do community planning for transportation. I encourage you to take advantage of that. There have been a number of webinars on how to do that. So please go through that. And if you can't find them, Vicky will be happy to help you out there. But one of the things you want to consider are your community goals and your tribal rules and your tribal culture in all of this. That's going to make a significant impact on what you go. The VIX of vehicle mix. Some villages have um, more pickups than others. Some are entirely ATV. Some have some larger uh, equipment that is moving in there. And we also have pedestrians on some of the roads. Other roads don't have it. So we need to consider all of that. And also driver behavior. Unlike most of our roads in the on most of our highway network, young drivers are part of that mix, and we have to account for their behaviors and and be able to ensure the safety of them as they traverse our roads. Enforcement limitations are very limited on that. Sometimes some villages have none, some have some, and some have a bit more, and that's going to vary throughout all of this. So one of the things we looked at as we put this together was how can we minimize the requirements for enforcement? We also recognize that a form of enforcement is oftentimes peer pressure. So we've tried to include that. And of course, the local environment and conditions. Some of you live in very dry climates. Excuse me. Others live in wetter climates. Some live along the rivers, some live in the higher parts of the state. So we want to make sure that we can account for that. Next one. We also, you know, the short travel distances are very much a part of the village, as we showed. Uh, some villages have less than a mile, typically no more than about 3 or 4 miles. And so those distances are going to be short. So we really don't have to worry about high speed roads, but we do recognize that around 30 miles an hour, 30 to 35 miles an hour may be kind of the top end of what we're looking at. Also recognizes this photo shows that a lot of pedestrians walking up and down the roads, many of them elders or young children in there, and we have to be able to account for that. Gravel surfaces, 90% of the roads are in our villages are gravel. Some don't even have a gravel surface course. They're basically silt roads, and we need to be able to take that into account. And as you'll see in a little bit, things like stopping sight distances and stopping distances and curves, all of those are impacted by that. And so finally, as we go through this, we'll talk a little bit more about the design and the function of our roads and how they fit together. Next. Your primary modes of transportation, ATVs are year-round dominant mode, um, even though most of the ATVs are not supposed to have multiple riders on them. In most cases, they do, so we have to recognize that and account for that. Snowmobiles in the wintertime, we see a fair number of those moving around and need to account for that. Uh, Pickup use, most of those in the villages typically are to move freight from the airport to the community or something like that, or around the community. And then freight, as we see in this photo, is often done via trailers, and we have to account for that in our turning radii, and those kinds of things. Next slide. Okay, as we said, road conditions we have to account for primarily road or gravel or native materials. Um, the Lucky Villages uh, have do have gravel, but many of our villages are silts and sands and river materials, and that's very much a part of what we have to account for. And then those really have much lower friction coefficients than do pavements, and we have to account for that. And we have some um, graphs and charts for that. And then there are certainly impacts to the stopping distances of our vehicles as a result of that. And we've provided those. It's probably one of the more difficult things we had to come up with, but luckily they do exist and we were able to take it and recognize that there's limited maintenance on these roadways. Some communities have better equipment than others. Some have essentially no equipment, and in some cases they're using nothing more than a drag behind a four-wheeler to try to maintain the roads. So we've got a wide variety of maintenance activities going on these roads. Next. Okay. In order to try to bring things into focus, um, we went through a number of iterations trying to figure out how to do functional classifications. Um, the roads for the classifications for most of the roads that we use on our highway transportation networks simply did not fit the village. So we came up with really three types. The non-core roads, which we'll talk about, the primary roads, which we call the core roads. The core roads are typically within the village, and then we have the primary streets and the residential streets. And in the guide, there's a graphic chart like this, but I'm going to take each one of them and talk about them individually. Next slide, please. Yeah. Non-core roads are the roads that are going out to the airports or the landfills or material sites, they're typically outside of the village. Um, and they're often, many cases, they were built by maybe Alaska DOT and to a higher standard than the village would have been able to afford, especially going out to airport. In some cases, they're even maintained by DOT, or at least paid for, the maintenance is paid for by DOT. In the case of airports, equipment may be able to use, airport material may be able to be used for maintaining those. They are, as I say, higher speed, higher designs, standards, and uh, you can see that as a function of the width and the curves and all of those are going. They're typically a little bit longer in areas. Many airports are a mile or two away from the village. The landfills are often a mile or two, so they tend to be higher standard, longer roads, and used at much higher speeds. Next, please. Okay. The core roads, they're the primary streets. Well, many people would consider them the main street. They connect community destinations such as the store, the post office, the uh, core utilities, and the school and those kinds of things. Um, and as such, they're mixed use. We've got pedestrians walking through those areas, ATV, and in many cases, equipment moving about. So they tend to be a little bit wider. They tend to be a moderate speed, not as high as the non-core, but they tend to be a bit higher speed than within the residential areas. So we've created a little slightly different standards for those roads, and we'll talk about those in a few moments. Next. Okay. The core roads, the residential areas, those are the ones that are gaining access to the homes. They have a very high pedestrian presence, often children playing in the streets. That becomes more or less their park uh, where they play there. They tend to be narrower and a bit lower speeds as part of that. Probably a little less in the way of, say, pickups and equipment than you would have on the core um, areas. And so in this case, we're just downgrading the sizes and widths and speeds of those roads. Next. Okay, so at this point, I'm going to turn it over to Nathan, and he's going to dig into some of the details of the road, each of these roads, and how they all fit together in providing that. As we've said, the uh, a lot of the information that we're going to provide you are minimalistic in nature. If you happen to be one of the lucky ones with plenty of gravel, want to widen them, that's fine. Um, and so you need to look at what you have and adjust this guideline to meet your needs, desires, and abilities. Nathan?
Yeah, thanks, Billy. And as Billy noted earlier, or and just said and noted earlier, the intent of this guide is to provide some flexibility, but what we have also done in certain places is made it slightly more restrictive or a little bit more specificity than in what folks might know as the Little Green Book or the guidelines for very low volume and local roads, which is applicable for under 400 ADT. And really that comes into play here with the design speeds. So as Billy noted, really thinking about function, so the non-core versus the core road, which will drive how wide a typical roadway will be. But what we've done here is to restrict the design speeds down to 40 miles an hour and under, where then your posted speed would be about 5 miles an hour under that, with the core and residential streets being a design speed of 25, and which keeps the posted speed at 20. So that does a couple of things. It minimizes the amount of dust that's being created, and extends the life of the wear surface. So the core streets, primary residential, being 20 to 25 miles an hour posted, and then the non-core going up to 35 posted, or a 40 mile an hour design speed out. Again, as Billy mentioned, those going out to either the airport, landfill, material source, or other community or cultural sites outside of that are outside of the village, like say like a cemetery. As far as typical roadway sections go, being fairly flexible there. Not all cross sections will require a ditch or a back slope, but where they're needed, and we'll look at some other references here in a minute. But there are other resources to go for the design of those, and where appropriate, we've referenced those in the design guide. In terms of roadway widths, like I just mentioned previously, it's going to be driven primarily by the suggested design speed. So we're looking at 14 to 24 feet as the typical range. One should consider a few different factors in that they are determining the roadway width. Like I said, first and foremost, the design speed. So obviously a higher design speed, or having multiple uses, pedestrians present, or the need for parking, that's going to necessitate a wider road. Um, um, if you have large trucks or equipment, those require more width. If it's a two-way operation, so you have vehicles coming in opposing directions, you would want to ensure that there's enough space for passing, and then also providing extra width on curves. But like I said, in general, you're looking at a little bit wider on the higher design speed, so up to 24 feet on the non-core roads, and then 14 to 18 feet within the core roads. In terms of grade and crown of the road, keeping it under 6% in general is preferred. If the road happens to be in a more mountainous terrain, potentially increasing by 2 to 3% there, but certainly keeping any grades at 3% or under in the vicinity of intersections. And then for crowns, if it's a scenario where you have a little bit wider road, so 16 feet or greater, again on those the primary within the core or the non-core roads, having a crown with 3 to 5% toward the outside of the traveled way, but the narrower ones, no need for a crown, and just it slope it one direction or the other. For turnouts and widening, having the ability on narrower roads for passing. So if for example, the scenario is we have one of these narrower residential streets, and it is two-lane operation, and there isn't enough space for vehicles to pass, rather than having the entire length of the road itself be having a wider width, is intermittently providing space with wider widths for pullouts in. There's a federal highway guide, which is the Federal Highway Star Guide, the small town and rural multimodal networks guide, that has some great resources on providing these that type of turnout on these smaller roads, but also having widening where there is home access. So maybe out to for 15 to 20 feet, having a little bit wider area in front of the homes. In terms of roadside design, that we're now talking about the area next to the travelway, not the travelway itself. In many cases, and in many design philosophies, this area is crucial for safety if a vehicle were to leave the road. Oftentimes, in villages, it's not practical, or it's just one is not able to provide shoulders because of either the topography, there might be obstructions or right-of-way issues. So making these wider roads might not be achievable. Having flat road sides can be difficult. Um, Large clear zones, or putting in traffic barriers is probably not cost effective for these types of roads either. Again, if we're keeping them at low design speeds, there's not going to be a great need for large clear zones. So designers should just apply their judgment in some of these roadside design features. We want to avoid over design. The purpose and intent, as Billy noted about the ultra low volumes guide, is to really scale down some of these things, to make them more appropriate and contextualized within these smaller villages. So for clear zones, a clear zone being in effect a flat obstacle-free area along the roadside for driver recovery. If a driver were to start veering off the road, then perhaps they could steer and navigate back onto the road, or stop safely. Typically, these are going to be 7 to 10 feet, which is commensurate with the design speeds. But we would also want to increase those by about 50% on curves. And if possible, flat recoverable slopes are preferred. A flat recoverable slope would be something 4 to 1 or shallower. In terms of barriers and guardrails, tried to avoid those when possible, and only use them when warranted. There is cost and maintenance associated with barriers and guardrails. If something does warrant a guardrail or a traffic barrier, there is the Federal Highway Roadside Design Guide that provides information on the design of those. Next slide. Oops. Yeah. Drainage. Um, drainage. I always tell students in my highway design classes that the three D's of good road design are drainage, and drainage. So proper drainage is critical and crucial for a number of things: maintaining safety, preventing erosion, and just prolonging the lifespan of the road in general. When I say drainage, I'm talking about structures like ditches, culverts, in some cases, storm sewers, bridges, things like that. The state, in the manual, we have referred folks to the State of Alaska Drainage Manual. There's a hyperlink in the document that will take you there. But also make sure if some of these drainage structures are required, that you are consulting appropriate agencies for permitting if you have to cross or impact existing water bodies or wetlands, streams, creeks, things of that nature. Moving on to some geometrics. Stopping site distance. What we've recommended here is to adjust for ATVs or utility vehicles. The idea being, if this is the primary design vehicle, then we can adjust the conventional stopping site distances that are assumed or calculated based on passenger vehicles. We pulled from some research that looked at braking and stopping site distances on varying surfaces and grades for both ATVs and UTVs, and an illustration of that is shown on this slide here. What we also did was, just for the purpose of being conservative, that we were assuming novice operators, and also that we were on grades less than or equal to 8%. In general, these tend to be a slightly just ever so slightly greater than the stopping sight distances in the very low volume guide. We've also provided in there or in the guide in table 2.5 recommendations for both one-way operation as well as two-way operation. In terms of horizontal alignment, this one's kind of just textbook. When possible, just minimize curves, but really just using the simplified radius design. So the equations on this slide here are relating the design speed to the minimum radius requirement. That's going to be impacted by the super elevation and the side friction factor. So we've also in the guide provided recommended radii for both paved surfaces and unpaved surfaces. And just to show just an example of that here, that for paved and unpaved, that really we're just looking at two different values of side friction factors for those. So the minimum radius on paved surfaces ranging from 85 to 530 feet for up to a 35 mile an hour design speed, or 60 feet up to 545 feet for the unpaved surfaces. And then also providing some guidance on the horizontal sightline offset. So essentially how far one needs to clear off the inside of the radius or the horizontal curve in order to maintain stopping sight distance. So you're going to remove any obstructions that are in effect impeding sight distance on the inside of that curve. For vertical curves, we want those to be simple, smooth, and gradual. Again, we are talking about low volume roads, trying to keep speeds to a minimum. So as far as crest vertical curves are concerned, being at least long enough to provide the appropriate stopping sight distance. If there are constrained situations, one might consider reducing the speed enough so that that sight distance is maintained. But in general, the length of crest vertical curves and the length of sag vertical curves can be computed using the standard AASHTO method. For intersections, traffic control in intersections, we're oftentimes looking at very low control environments. When I say low control environments, I mean either no traffic control at all, yield signs, or stop signs. So if there's a situation where there is sufficient sight distance, or you have two-way single roads that have sufficient sight distances that are intersecting each other, then traffic control may not be necessary. If you have a two-way single road that's intersecting a minor road or a two-way single road that is intersecting minor access or an industrial access road, you might consider using yield signs in that case. And then in the case where you either have obstructed or restricted views that would require a road user to stop to adequately observe traffic, or if you are in or near to a school zone, areas with significant pedestrian or other multimodal user considerations, one might consider using stop signs in that case. So just to show what we're talking about with sight triangles is having enough time and enough distance to observe vehicles on conflicting approaches with enough time to either come to a stop or change trajectory speed sufficiently as to not create the potential for a crash or an incident. As I mentioned multimodal user considerations. Um, Shared space is common in rural villages and communities, and oftentimes with limited separation. So not having an actual separated side or a raised sidewalk, not having a separated shared use path. So really incorporating into the roadway width and design a way to accommodate pedestrians or other users. I mentioned the Federal Highway Small Town and Rural Multimodal Networks guide before. Um, but if we have paths that are intersecting roadways, making sure that those also have sufficient sight distance, that we are in some way creating a refuge area for pedestrians to wait to cross a roadway, making those crossings so that a pedestrian can do it at about 90 degrees to minimize the crossing width. Um, and as I just mentioned, the Star Guide does have a lot of schematics that illustrate different paths and signage and roadway markings that are appropriate for pedestrians in these low speed and low volume scenarios. In terms of bridges, the bridge widths should be consistent with the roadway. They should have all the necessary safety features that come with bridges. Having signage appropriate to warn drivers that there is a bridge ahead, or that there are bridge features that one could strike with a vehicle. Um, uh, in the guide, we have some suggested bridge widths by roadway type. So whether that is paved, unpaved, or if it's a one lane bridge sort of scenario. As far as signage goes, signs can be an important part of road safety, but trying to keep signage as to a minimum, using the minimum practical sizes as warranted. Signage is good for enhancing conspicuity. Um, Really, what we do we in the guide we have directed folks to the manual and uniform traffic control devices that provide standards and guidance on signage. Um, there are in extenuating circumstances, if there is a need for signage that does not exist, there are channels and mechanisms for going through a process to get those approved. And Billy and I have helped out in that process before. Typical types of signage that we would be thinking about would be obviously stop and yield signs. Speed limit signs to some extent, but often in villages, speeds aren't posted. Enforcement can be hard. I think as Billy noted, a lot of the speed enforcement is done more so through informal mechanisms. Other folks in the village. Um, Having maybe do not enter, no trucks, one-way signs, those might be appropriate. No parking signs might be another more common sign. um, Road being closed to local traffic is another one we see commonly, or having posted weight limits, either for part of the year or the year in its entirety. Then for roadway lighting, obviously we have long periods of darkness that are inherent to our high latitude locations. Um, Lighting can be an attractive feature for that reason. Having lighting is also desirable for pedestrians, especially with children. Billy noted, it's not uncommon to have the residential streets as a place of recreation, and so having lighting can improve safety by increasing visibility near to roadways. Um, some villages desire having lighting for the purpose of being able to see wildlife such as bears or moose, so it creates some personal safety there. but also having lighting generally placed at intersections. Intersections also tend to have high pedestrian activity. Having lighting near the school or the village store, community hall, other gathering areas as well. So if there is a case where one needs to or wants to use lighting, the guidance for that is in the guidelines for the implementation of reduced lighting on roadways, and we provide a link for that in this document as well. For the reduced lighting on roadways is again just being more commensurate with these lower volume type facilities. So just to hit on a couple of the key takeaways, what we just ran through are the primary sections of the Alaska Village Road Guides, but that we are designing more for context and not just relying solely on the standards, and recognizing that we have a lot of mixed use, and so trying to uh, uh, consider elements that emphasize and prioritize safety for all of those mixed users. As Billy noted, flexibility is key, and in here we've inherently included elements that provide a suite of options rather than specifying exact elements. And obviously, again, as Billy noted, having variability in materials, a variability in needs, and so really allowing local conditions to drive the decisions of the roadway geometrics and features. So at this time, I'll just go ahead and open up to questions. If we need to cycle back and go to a slide, just let me know. And Billy, do you have any other closing comments you'd like to make?
No, I'll wait to see what questions we got before we close it out.
Yeah,
Okay.
people can either raise their hand to post a question in chat or post a question in the Q&A. Any of that will work. There are multiple options. So chat, Q&A, or raising your hand. If anyone has questions, happy to take them. All right. Just for some of the items that Billy and Nathan mentioned, I'm going to drop links in the chat. So I have dropped the drainage highway of State of Alaska drainage manual link into the chat. I'm also dropping the Alaska TTAP resources page into the chat because there's links to a variety of the documents mentioned there. Here's the link once again for the design guide itself. So, all right. So does anyone?
And I'll throw a couple of the other ones I referenced more frequently in there as well. So the Federal Highway Star Guide.
Okay. Nathan, you did that just to host and
Host and
panelists. You
panelists.
need
Sorry,
to switch that to everyone.
Sorry, Vicky.
That's all right. It defaults to that. Okay, we've got a question. We have a question posted from Dan who was saying it was hoping we would be discussing types of constructions allowed, i.e. cribbed roads, etc.
Okay. See if I can hit that. As far as the types of constructions that we're allowing, um, in this guide, we're not going to, we purposely did not go into the design of the embankment itself. Um, Rather, we focused on the geometrics and the speeds, stopping sight distance, and all that goes into developing the geometrics. The design of the embankment itself is really left to the standard practices and other guides. The gravel roads course that we're teaching has a lot of that information in it for the purposes of the design of the embankment. And if you're going to be putting a surface course on it, we've provided information and other resources for that. I know there's been a lot of discussion about having a gravel roads design process. Unfortunately, there's only one or two out there, and they don't really fit our needs. So I'm talking to DOT to figure out how we can develop that manual. Dan, I hope that answers your question, but it does, I know it's not very satisfying, but that's where we're at.
All right. So lots of links showing up in the chat for people. If anyone has any other questions, we still have some time left before before the allotted hour is up. So if anyone wants to ask an additional question, either raise your hand or post in the chat. Oh, there we go. All right, Randall, I have allowed you to talk. So, Randall, you're unmuted, so you can talk. Well, you raised your hand. So just unmute and you can ask your question. Randall, I can see you're showing is unmuted. Okay. I guess having volume, Randall must be having volume issues. Okay, Dan, all right. Dan, I've allowed you to talk, so you should be able to unmute and ask your question.
Yeah, can you hear me now?
Yes.
Okay, thanks. Yeah, so I was kind of envisioning when we were talking about village roads. We live in a maritime environment, and a lot of, well, not a lot, but a big portion of our village roads here were built with cribbing because of the depths of the overburden. We've got swamp some places that goes down 10, 12, more feet. So they've just kind of laid logs over the top and then poured gravel over that with, of course, some culverts underneath for drainage. And that's kind of what I was expecting when I saw this one. So will the gravel roads um, training that's coming up, is that going to cover types of constructions like log roads, over cribbing and things like that?
I can certainly put something in there that covers that. I didn't have it. What you're talking about is a technique called corduroy,
Yeah.
and it's been around since the 30s, 1930s. So I can certainly cover that and what people are doing. The modern analog of the old corduroy or geosynthetics, and Dan, that's a course in and of itself, and that's certainly we're willing to put something like that together uh, for you in order to accomplish that goal. So we'll cover it slightly in the gravel roads course, but Vicky, will you make a note for us to talk about maybe putting together a course on the use of geosynthetics for road construction?
Sure. I'm making a note.
Okay, Dan, I'll see what we can do to get something together for you.
Thanks a lot. I appreciate it.
Okay. All right. All right, anyone else with questions? I'm not seeing any more raised hands or seeing any more questions written in the Q&A box or the chat. If you do have questions that you have not been able to get answered, please feel free to email. Email me. This is Vicky. I sent out the announcement about the webinar, so everyone should have my email. So feel free to send me questions and I can pass them on to Billy and Nathan as needed. And on that note, everybody gets a little more, Q&A just posted a question. Randall has a question about how do we apply for funding for streetlights?
Um, there is both Federal Highway and BIA have a program where you basically you come up with a plan and a construction project, which they will pay for if you use it, and you can go through the process and apply for a grant to do that, and you're competing with a number of other people to do that, so you may or may not get it. But um, Vicky, you've given several courses on how to put together grants and the TTT program. You want to go just hit a couple of highlights of that for us?
Well, we haven't done a course on it, but we've had a few webinars on that. One of the Tribal Transportation Program safety funds are one of the primary locations for applying for grants to do lighting projects because they're clearly justifiable under the safety umbrella. The there was, I don't remember whether it's still open or not, but that it's the in the they're certainly part of the Safe Streets for All grant program is one of the options for applying for lighting resources. And I don't know what the comparable sort of program is on the BIA side, but I do know there is a safety category that's additional in addition to that for that. Um, for that. Okay, and as a follow-up to that, Leanne has, where is a good place to order streetlights? She got a streetlight grant through the TTP Safety Fund and I'm looking for recommendations. So Nathan or Billy, do you have any recommendations on that? Leanne, that might also be something to email us if there's not sufficient detail here.
I really don't have any recommendations as to what. There are a number of companies that produce streetlights. The current trend is to use LEDs because of the cost is considerably less than the sodium uh, streetlights of the past. So most people are moving to that. One of the complaints I've heard about from those, though, especially up on the North Slope where they've got a lot of polar bear, is that the polar bear hang out just outside the curtain of those lights because the light is very sharp. The cutoff is very sharp, where the sodiums are kind of gently spread, gently faded out. Um, I mean, we could probably go through and find some companies that do that, but my best suggestion is to Google those companies or to get a hold of the folks over at DOT and or some of the local contractors, and they can tell you where they get theirs from. Nathan,
And Billy, I would just add to that that there are now a few companies, depending on Leanne, based on your location, there are a few companies now that are integrating solar panels, into the streetlights as well to offset some of the electricity burden of their operation as well.
Okay, Dan had another question.
Yeah, it's not so much a question, but more of an address to the street light question for funding. So I've only been with our roads program for probably, I think, 3 or 4 years, but I previously worked with the transportation coordinator for our tribe before that through the city. And the tribe had not been expending all of our annual funding, our roads funding. So they worked with the tribal administrator, the city worked with the tribal administrator, and they said, well, what can we do to help the city out? Because the city didn't have any money and we had a bunch of burnt out streetlights, and they just simply used our annual program funds to purchase some streetlights for the city and had the city install them. So, I mean, if you're thinking that you need a grant, that's not necessarily true. Correct me if I'm wrong.
No, I think that's right. Streetlights are a valid and replacing existing streetlights is certainly a valid part of the TTP maintenance fund ability. That's a maintenance activity under the Tribal Transportation Program funds. And so you certainly can use regular TTP funds for that. But yeah, I would say basically any safety grant, if you need additional grant money, is a work for that. All right, next question is, when developing the roads up for an area that have less gravel material on site and have to be shipped to the work location, I think a rock bucket mobile jog crusher that can be attached on an excavator would help move a road and other projects along when able to make their own gravel on site, and then rather than having shipped from other places. I think that, Billy, that's correct, but it also depends on you having rock available.
Yeah. Where you've got a situation where you need to crush the rock down, those systems work very well. Be careful that you pick one large enough for the rock that and the hardness of the rock that you're working with. Alaska DOT has used several of them up on the haul road over the years, and they've had good luck with them. But also they're very high maintenance. So you have to take that into account. Replacing the carbide teeth as essentially a daily activity with those things. But they do work well, and they make them all the way from fitting on a Bobcat all the way up to a 966 loader. So you just have to balance with your needs.
All right. Okay. So we're almost to noon. There's probably time for one last question if anyone has something that they want to ask. And I will say everyone is welcome to email as well if you have, and particularly if you have a very detailed question. One of the roles of the TTAP is providing technical assistance to tribes on their on their transportation projects. So we're happy to provide that assistance in multiple ways. So going once, going twice. All right, well, thank you everyone for attending, and keep your eyes open for the next ones, and I will be ending the recording now.